Problem number 17, prove that integral 0 to 1 x sin inverse x by root of 1 minus x square dx equal to 1. Here we use substitution method. Substitute sin inverse x equal to t. Then this becomes 1 by root of 1 minus x square dx equal to dt. Again sin inverse x equal to t, therefore x equal to sin t. Here integral x sin inverse x by root of 1 minus x squared dx equal to x is sin t, sin inverse x t, dx by root of 1 minus x squared is dt. Now integral t sin t dt. We apply integration by parts. U equal to t, dv equal to sin t dt. Then du equal to dt. Integral dv equal to integral sin t dt, that is v equal to minus cos t. Now you apply the formula integral u dv equal to ub minus integral v du. Integral u is t, dv is sin t dt equal to u is t, v is minus cos t, minus v is minus cos t, that is plus cos t dt. Now this is equal to minus t cos t plus cos t. If you integrate this, you will get sin t, right? Then again you substitute the value of t. What is t? T is sin inverse x and sin t is x, dt is dx by root of 1 minus x squared. The given problem is minus t is sin inverse x. Before that, here there is no value for cos t, only we have value for sin t. Therefore, we write this as root of 1 minus sin squared t plus sin t. The next step, you substitute the value of t is sin inverse x. Under root of 1 minus x squared plus sin t is t. Now sin t is x. Now therefore, limit 0 to 1 x sin inverse x dx by root of 1 minus x squared equal to minus sin inverse x into root of 1 minus x squared 0 to 1 plus x 0 to 1. Now this is equal to minus sin inverse 1. But here 1 minus x, in the place of x you substitute 1, 0, this becomes 0. Again if you substitute 0, this also 0, minus 0, plus here in the place of x you substitute 1, then 0. Therefore, this is equal to 1. Problem number 18, subdivision 1. Mention the suitable property of definite integrals to be used to evaluate this integral, that is integral 2 to 4 root x by root x plus root of 6 minus x dx. Also find its value. Here we have to mention the suitable property. That we are going to apply the property integral a to b f of x dx equal to integral a to b f of, you add these two limits a plus b minus x dx. This property we are going to apply. Now number 2, we are going to evaluate this integral. Let I equal to integral 2 to 4 root x by root x plus root 6 minus x dx. Now you apply this property. Here a equal to 2, b equal to 4, a plus b equal to 6. Therefore, this I equal to integral 2 to 4. Now in the place of x you substitute a plus b minus x, that is 6 minus x by root of 6 minus x plus root of 6 minus x dx. Now this is equal to integral 2 to 4 root of 6 minus x by root of 6 minus x plus 6 minus 6 is 0, minus of minus x plus x, that is root x dx. Again this is I equal to root x by root of 6 minus x plus root x dx, integral limit 2 to 4. Therefore, this is again I. Adding these two, we get I equal to this one, I equal to this one. Therefore, 2I equal to integral 2 to 4 this first I, root x plus root x minus x, you can dx plus integral 2 to 4 second I, that is root of 6 minus x by root 6 minus x plus root x dx. Now adding we get 2 to 4, same bracket, within a same bracket, that is root x plus root 6 minus x plus root 6 minus x by root 6 minus x plus root x dx, isn't it? Now this is equal to integral 2 to 4. Take the LCM. Root x plus root 6 minus x, you get root x plus root 6 minus x dx. These two get cancelled. Therefore, integral dx, that is x, limit 2 to 4. That is 4 minus 2, that is equal to 2. That's all.